is day 9 of the 30-day LeetCoding challenge, and the question for this day is called Backspace String Compare. So let's go ahead and read the question. Given two strings S and T, return if they are equal when both are typed into empty text editor. So we have the hashtag means a backspace character. So if we look at the example right here, S and T. So right here, if we actually type this out, we type A and then type B and type backspace and then type C, we expect to get AC because this backspace will erase B and T here. So we type A and then we type D and then we type backspace, and then we type C. So we expect to see C as well. So there's two string. If we actually type them out, they should be the same string. So that's why it returned true. And for this one, this is a special case. So when you type A and then you type backspace, so it means that you delete A and then you try to delete another one, but it's empty. And then you type C. And so your final string would be C. So in this case, for T, you type backspace, so you delete nothing, and then you type A, and then you type backspace, and then you type C. So both of them should have C. So it should return true. For this one, so you type A and you delete A, and then you type C, and then you just type B right here. So in this case, it's not the same because one give you C and another one give you B. So it kind of makes sense, and I think that this type of question is really great. It's wonderful. This is a type of question that kind of show you the application of itself. I could see this type of program would be used somewhere where to see if it use what letter a user type when they combine them with backspace. I see a lot of useful in this. So let's think about how would we approach this. So whenever we have something like a string, it's not easy to play around. So what we want to do is we either want to convert it to a list, but since this case is order is matter, when we're talking about order is matter, we usually think about either a stack data structure or a queue data structure. And for this case, I think we should use a stack data structure because every time we delete, we want to delete the last one that we just added. So it's LIFO, last in, first out. So whatever we added earlier, whatever we added last, we want to delete that. So in this case, we added B last, so we want to delete B first. So I think stack would be something that we want to use for this problem. And for this case, if the stack is empty, we don't want to delete anything because for this case, this backspace we delete A, the other backspace we delete nothing. So that's something that we have to look out. And the time complexity for that algorithm would be ON. So since you ON plus M, where N is the number of character of string S, and M is the number of character of T. So what we want to do is we want to create a stack. And the space complexity is still ON plus OM as well. And this is follow-up question that they want us to do O1. We'll talk about it later. But let's do it with a stack. So let's call stack is this, and T stack is this. So what we want to do is we want to go through the character S. So if the character is not equal to the hashtag, you want to add it to the stack. Else, so if it's a hashtag, and if our stack is not empty, so if that's true, we want to so if the stack is not empty, we want to delete the last element that we just added to the stack. And then we do the same thing for T. So that we change this to T, and this to T, this to T, this to T. And then we can like write our own function to compare if the stack is the same as this stack. But what else we can do? Like the other way that we can do is like we convert the stack into like a set. And the reason that we want to convert it to a set, because like if the stack is a set, we can compare them. Right now it's a list data structure, and list data structure doesn't allow us to compare them directly. So what we want to do is we want to convert those to stack. I think to a tuple, not to a set. So let's go over our code one more time. So the idea is like we use two stacks. One stack store the S string, second stack store the T string. And what we want to do, we want to add all the character to the stack correspondingly. So we want to add all the character in S into like stack S stack. But whenever we see a hashtag, we want to delete the last one. And that's like, for example, right here. So first we add A, and then we see hashtag, so we want to delete A. And then we see another hashtag, so we want to delete whatever in the top of the stack. But since it's empty, we don't do anything, as you can see right here. We only delete when the stack itself is not empty. And similar thing with T. So it's like once we done that, we only left with the final string that should be in the terminal or in the program. So this should return us like a true or false. So if string S is the same as like string T, it should give us a true. So we can like run the code. Nope. Runtime error. Yes, I spelled stack incorrectly. Here we go. All right, let's submit it. There we go. So the solution is accepted. Well, like I mentioned earlier, like this algorithm will take O of n plus m. N is like the number of character in S, and m is the number of character in T. And space complexity is the same because like we use this two stack right here. You can improve this by using like two pointer, but I'm not going to discuss about it. If I do, I will make a new video about it. Alright, thanks everyone for watching.